Hello everyone. Today I'll be talking with you about the mechanical advantage of pulleys in a crawler crane. This was prepared by Chase Beals, Cord Childs, Kevin Childs, and myself, Caleb Dixon. So a little background on the project. We are relating material learned in Dr. Mativo's dynamics class to a real-world situation. And by doing so, we are comparing material learned in Chapter 11, kinematics of particles, to a pulley system in a crawler crane, specifically the crawler crane that is used in the Sanford Stadium renovations being done by TPR Construction. Some history on the crane. It is a 348 high lab 5 lattice boom crawler crane constructed by Link Belt Cranes in Lexington, Kentucky. It consists of 38 pulleys, giving it a mechanical advantage of 38 to 1. The crane is efficient because it uses hooks and blocks. And the hooks and blocks are segments of the crane containing sheaves and pulleys on the inside. And at the end of the crane, a rope is paired with a headache ball to attach and lift loads for the crane. So for our experiment, we brought it down to a smaller scale and used a tough tug rope hoist. And the rope hoist consisted of 4 pulleys, giving it a mechanical advantage of 4 to 1. The hoist was placed on a scaffold. The load was a 3.11 pound wrench, and that was attached to the bottom of the pulley system. At the end of the rope, we had attached a scale so we could be able to accurately record the force being applied to lift the wrench. The scale was pulled in an upward direction to show the force needed to lift the wrench, and this experiment was ran 3 times to give us an accurate data set. The same test was ran without the wrench so that we could determine the load of the hoist. So as you can see on this, we have an image of the tough tug hoist. We have an image of how we conducted the experiment. So we had the scale attached to the rope and we were pulling it upwards. And on one end we have the weight of the wrench. So for the results, we were able to get that the force to lift the wrench was, for trial 1 was 1.12 pounds, trial 2 was 1.11 pounds, and for trial 3 was 1.1 pounds. The force of the wrench without the hoist was 3.1 pounds, 3.11 pounds, 3.11 pounds. So that stayed consistent throughout. The mechanical advantages, though, they changed slightly due to the force changing slightly. So for trial 1, the mechanical advantage was 2.78 to 1. Trial 2, it was 2.8 to 1. In trial 3, it was 2.83 to 1. And on this slide, this gives you a breakdown on how we calculated the mechanical advantage of our pulley system. And the way you do that is you do output divided by input. In an example, trial 1, the output was 3.11 pounds and the input was 1.12 pounds, giving it a mechanical advantage of 2.78 to 1. So for this experiment, we found that the mechanical advantage of the pulley system was 2.8 to 1, which is lower than the recommended mechanical advantage of 4 to 1. And where we're getting some error is we used a lightweight wrench. There was friction in the pulleys, there was friction in the rope, and the weight of the rope. We didn't calculate the weight of the rope as well. And all 5 of those gave us some error in our calculations, thus driving the mechanical advantage down. The hands-on experience was successfully related the material learned in Chapter 11 to a crawler crane, though. And some recommendations for further projects are use a heavier object to show a more accurate mechanical advantage. And this slide, we wanted to put it in there because without the mechanical advantage provided by the pulleys, the Georgia Bulldogs would be stuck with an archaic, non-SEC champion-worthy stadium. So for this slide, you can either click on the video to play it, or you can go to the link below. I would just like to thank everyone for watching this video and have a great day.